Hello everyone, welcome to today's session. So today we'll be discussing logistic regression and let's move forward and understand what and why of logistic regression. Now this algorithm is most widely used when the dependent variable or you can see the output is in binary format. And so here you need to predict the outcome of a categorical dependent variable. So the outcome should be always discrete or categorical in nature. Now, by discrete, I mean the value should be binary, or you can say you just have two values. It can either be 0 or 1. You can either be yes or no, either be true or false, or high or low. So, only these can be the outcomes. So, the value which you need to predict should be discrete, or you can say categorical in nature. Whereas in linear regression, we have the value of y, or you can say the value need to be predicted in a range. That is how there is a difference between linear regression and logistic regression. We must be having a question like why we are not using linear regression. Now guys, in linear regression, the value of y or the value which you need to predict is in a range. But in our case, as in the logistic regression, we just have two values. It can be either 0 or it can be 1. It should not entertain the values which are below 0 or above 1. But in linear regression, we have the value of y in the range. So here, in order to implement logistic regression, we need to clip this part so we don't need the value that is below 0 or we don't need the value which is above 1. So since the value of y will be between only 0 and 1, that is the main rule of logistic regression. The linear line has to be clipped at 0 and 1. Now, once we clip this graph, it would look somewhat like this. So here you are getting the curve which is nothing but three different straight lines. So here we need to make a new way to solve this problem. And this has to be formulated into equations and hence we come up with logistic regression. So here the outcome is either 0 or 1, which is the main rule of logistic regression. So with this, our resulting curve cannot be formulated. So hence our main aim to bring the value to 0 and 1 is fulfilled. Now that is how we came up with logistic regression. Now here, once it get formulated into an equation, it looks somewhat like this. So guys, this is nothing but an S curve, or you can say that sigmoid curve, a sigmoid function curve. So this sigmoid function basically converts any value from minus infinity to infinity pure discrete values, which is logistic regression wants, or you can say the values which are in binary format either 0 or 1. If you can see here, the values are either 0 or 1, and this is nothing but just a transition of it. But guys, there's a catch over here. So let's say I have a data point that is 0.8. Now, how can you decide whether your value is 0 or 1? Now here you have to concept the threshold, which is basically divides your line. So here threshold values indicates the probability of either winning or losing. So here by winning, I mean the value is equals to 1, and I losing, I mean the value is equal to 0. But how does it do that? Let's say a data point which is over here. Let's say my cursor is at 0.8. So here I check whether this value is less than the threshold value or not. Let's say if it more than the threshold value, it should give me the result as 1, and if it is less than 1, then it should give me the result is 0. So here my threshold value is 0.5. I need to define that if my value is 0.8, it is a more than 0.5, then the value should be rounded off to 1. Let's see if it is less than 0.5. let's say I have a value 0.2, then should reduce this to 0. So here you can use the concept of threshold value to find output. So here it should be discrete. It should be either 0 or it should be 1. So I hope you got this curve of logistic regression. So guys, this is the sigmoid S curve. So to make this curve, we need to make an equation. So let's see how an equation is formed to imitate this functionality. So over here, we have an equation of a straight line. It is y is equal to mx plus c. So in this case, I just have only one independent variable. But let's say if we have many independent variables, then the equation becomes m1x1 plus m2x2 plus m3x3 and so on till mn xn. Now let's put in b and x. So here the equation becomes y is equal to b1x1 plus b2x2 plus bx3 and so on till bn xn plus c. So guys, the equation of the straight line has a range from minus infinity to infinity. But in our case, or you can say logistic equation, the value which we need to predict, or you can say the y value, it can have the range only from 0 to 1. So in that case, we need to transform this equation. And to do that, what we had done, we have just divided the equation by 1 minus y. So now y is equal to 0. So 0 over 1 minus 0, which is equal to 1. So 0 over 1 is again 0. And if you take y is equals to 1, then 1 over 1 minus 1, which is 0. So 1 over 0 is infinity. So here my range is now between 0 to infinity. But again, we want the range from minus infinity to infinity. So for that, we'll have the log of this equation. So let's go ahead and have a logarithmic of this equation. So here we have this transform it further to get the range between minus infinity to infinity. So over here we have a log of y over 1 minus 1 and this is your final logistic regression equation. So guys, don't worry, you don't have to write this formula or memorize this formula. In Python, you just need to call this function which is logistic regression and everything will be automatically for you. So I don't want to scare you with the maths in the formulas behind it, but it's always good to know how this formula was generated. So I hope you guys are clear with how logistic regression comes into the picture. Next, let's see what are the major differences between linear regression and logistic regression. First of all, in linear regression, we have the value of y as continuous variable or the variable which you need to be predicted to be continuous in nature. Whereas in logistic regression, we have the categorical variable. So here, the value which you need to predict should be in creating nature. It should be either 0 or 1 or should have just two values to it. For example, whether it is raining or not, it is humid outside or it is not humid outside. Now it is going to snow or it's not going to snow. So these are the few examples. We need to predict where the values are discrete or you can just predict whether this is happening or not. Next, linear equation solves your regression problems. So here you have a concept of independent variable and the dependent variable. So here you can calculate the value of y which you need to predict using the value of x. So here your y variable or you can see the value that you need to predict are in a range. But whereas in logistic regression you have discrete value. So logistic regression basically solves a classification problem. So it can generally classify it and it can just gives you the result whether this event is happening or not. So I hope it is pretty much clear till now. Next, in the linear regression, the graph that you have seen in a straight line graph. So over here, you can calculate the value of y with respect to the value of x. Whereas in logistic regression, because of that we got a S curve. You can say the sigmoid curve. So using the sigmoid function, you can predict your y values. Moving ahead, let us see the various use cases where logistic regression is implemented in real life. So the very first is weather prediction. Now the logistic regression helps you to predict your weather. For example, it is used to predict whether it is raining or not, whether it is sunny, it is cloudy or not. So all these things can be predicted using logistic regression. Whereas you need to keep in mind that both linear regression and logistic regression can be used in predicting the weather. So in that case, the linear regression helps you to predict what the temperature will be tomorrow, whereas logistic regression will only tell you which is going to rain or not, or whether it's cloudy or not, whether it is going to snow or not. So these values are discrete. Whereas if you apply linear regression, you are predicting things like what is the temperature tomorrow, or what is temperature day after tomorrow, or all those things. So these are the slight difference between linear regression and logistic regression. So moving ahead, we have a classification problem. Size on perform multi-class classification. So here it can help you tell whether it's bird or it's not a bird. Then you classify different kinds of mammal. Let's say whether it's a dog or it's not a dog. Similarly, you can check it is reptiles, whether it's reptile or not a reptile. So in logistic regression, it can perform multi-class classification. So at this point, I have already discussed that it is used in classification problems. Next, it also helps you to determine the illness as well. So let me take an example. Let's say a patient goes for a routine checkup in a hospital. So what the doctor will do is perform various tests on the patient and will check whether the patient is actually ill or not. So what will the features? So the doctors can check the sugar level, the blood pressure, then what is the age of the patient? It is very small or it is an old person. What is the previous medical history of the patient? And all these features will be recorded by the doctor, and finally the doctor checks the patient data and determines the outcome of an illness and the severity of illness. So using all the data, a doctor can identify whether a patient is ill or not. So these are the various use cases in which you can use logistic regression now. I guess enough of the theory part. In the next session, we will see some of the practical implementation. If you have any doubt, you can add your doubt in our comment section. Thank you so much for watching.